Welcome, guys, to part 3. I hope it is recording my screen. I just hope so. But yeah, let's continue from where we left off. Um, okay, so we did question 2.1. Now we were left with the other questions from question 2. So let's continue. Okay, let me just drink some water before we start. Okay, so 2.2. Suppose that the above class has a load from bin member function that loads the contents of the array from a text file. Okay, so it loads the contents of the array from the text file. So by contents of the array, so it's information about the array. So this would be like the values at each index, maybe the size, the dimension, the dimension or the size of each dimension. Maybe it could be that, maybe rows, columns, values for values at each index. So yeah, they want you to, that's exactly what the file has. So obviously it's going to take in a string because it's going to take in the name of the file. So it's going to be taking in a string, and then it's going to be of type void because we're just reading from the file. We're not returning anything after reading, which declares a simple two-class hierarchy consisting of a base exception. So it's a two-class. So basically, there's two classes. That's what they're talking about, consisting of a base exception type and a specific exception type for an error that will occur if the object failed to open the text file. So basically, they're telling you that there's going to be two classes, one for the base exception. So basically, this is like the great grandfather or whatever of the exception, different types of exceptions. So because remember, with exceptions, it basically works as like sort of like inheritance. It works like that. So we're just doing inheritance. So always when you're doing exception handling, right? So obviously going to have called exception.h. That's going to be the header file, right? So this header file is only going to consist of this. So it's going to consist of class called exception, and then yeah, it's going to be like this, nothing more, nothing less. So I feel like it's good to demonstrate it inside code blocks. So let's demonstrate it inside code blocks. So let's just do this. So we have exception. No, I don't want to use the exception that's inside C++. So you do it like this. I just want to be sure. Okay, yeah. Okay, I hope it's a bit clear now. So this is always the ancestor. Always the ancestor of all the different types of exceptions. And we can have different types of exceptions. So this is the ancestor, or the start. The ancestor is basically like the starting point of the inheritance of the family tree. Remember, inheritance is all about family trees. So this is what they call the base exception type, as stated by the question paper. So this is like the base. This is where everything begins. That's where everything is. So that's how it's going to be. So the only thing that they want is just two lines. One with the base class or the ancestor class, the base exception type, and the other specifying the type of exception related to the question. So if you look at the question says which declares a two simple class consisting of a base exception type. That's just exception. It's just exception. It's not a specific exception. It's the ancestor for all exceptions. And then we have a specific one. This is not just, it's no longer just exception. This is now a specific exception data type or type for an error that would occur if the stream object failed to open. So basically, you should create a child class that represents. So that basically what they're telling you is that the name of that child class should be should name it in such a way it's related to opening the file. So the one that I would suggest you go for is the class. You say file not found exception. File not found exception. Then obviously inheritance, this is a type of exception. The type of exception. I don't think you have to put the curly braces, but okay, I think you do. Yeah, you do. Yeah, you have to put the curly braces there. Or maybe you shouldn't. But I don't, let me see. It is a type of exception. Let me just remove and see what's going to. Is there something that I'm missing here? Yeah, class not found exception, and then yeah, I'm sure it's something small. Let me just, because I haven't been doing exceptions in quite a while, but let's see. It expects semicolon. Okay, I did put the brackets though. I don't know why it's saying expecting the brackets. Okay, do this, yes. Invalid use of incomplete type class exception. Oh, I think it is. It just wants me to put that there. Yeah, they're just forgetting small things. So just make sure you put those curly braces, because if you don't put them, it's gonna assume that it's not even a class. It's like it's incomplete. So you're just gonna you need to put those curly braces there so that it knows, okay, this is a class. You just assume whenever, remember that the compiler is not that intelligent. It just doesn't check a lot of things, just checks the minimal things. So if it sees the curly braces, like, oh, okay, this is a complete class. Okay, I won't complain, I won't moan about it not being complete. It is complete. And then even when you're doing inheritance, you have to specify those curly braces. So yeah, we have that. And then as you can see, this is the type of exception, and you see it's related to my file. I just called it file not found because obviously when you're reading a file and you can't read it, that means you couldn't find it. And this is the very most common. This is actually how it's named behind the hood. I think there should be. Let me see. But I think there should be a file not found exception. File not found exception, but there should be an exception. Let me see. Okay, it's not. But there should be a file not found exception. Just that maybe I'm just thinking about Java, but yeah, this is because I know file not found exception in Java. It is there by default. So this is how I would name the class or the exception. It makes much more sense when you say file not found. Just name it like this if it's related to opening the file and you couldn't find it. Even if you don't give it a proper name, just giving it a name that relates to the file. So you can even, I mean, it doesn't really matter. You can even call it file not there. The file is not the exception. Just make sure you put that exception at the end. Because remember, this is the base class, and then this is the child class. So it's a type of a exception. So I'll just use class not found and as the answer. I'll just call it file not found. Question 2. Well, we asked in question 2. So 2.2. I think it's A. Okay, it's 2.2. There's no A or B. So this will be answer. Let me see if I can do something about this. Okay, let's do. Yeah, I just want to add colors there so that you can tell the difference between code and just text. So yeah, I'm just gonna leave it like that. Yeah, that should be fine. Yeah, so that's the answer for 2.2. You can call it any name you want, doesn't really matter, but file not found is the proper name for it. And yeah, trust me, when your lecturers see that answer, they're like, okay, this person actually understands what they're doing. And I didn't write any other code because they said so. They said, do not provide code for throwing in or handling the exception. By throwing and handling the exception, they mean this code. When you say try, this, and then you have, catch, right? Let's say you catch file on exception, ex, this. So they don't want to see this. They don't want you actually handling the exception. They just want to see you declaring the exceptions here. That's all they want to see. The rest, they really don't care because it's only 2 marks. So don't try to write extra answers to show them that you know and waste time. So don't do that. So 2.3, write code to protect the following using exception handling. Assuming that the class has been updated to raise the exception. Okay, has been updated to raise the exception types defined in the previous sub question. So this is now the load from bin, right? So what they want us to write is to write the following using exception handling. So we should write, basically they want us to write this. You see this code, they want you to write it using exception handling. So now this is where you actually supposed to put the answer. So now they were looking for this. This is where you actually handle the exception. So the try catch, what it does, right? So what try catch means, it's like try this and basically try this, whatever is inside here, try that. And then if it, okay, yeah, try catch is basically saying, okay, try this, try whatever is here. Okay, let's just use Notepad for this. So try catch is try whatever is here because it might throw an exception. An exception is basically it's something that you didn't expect to happen. As you can see, it's from if you look at the exception, the word exception is expect. It is something that you didn't sort of okay expect exception, but yeah, it's sort of like it's related. It's one and the same thing. It's basically in simpler terms that didn't expect it. It's something that you don't there's something that is going to happen that you didn't expect to happen. So that's what try does. It's like, okay, try this code, ne? But when you're trying this code, right, proceed with caution because there's something that might occur. For example, if the user tries to divide by 0, they can do that. But I also don't want I don't want the program to crash when the user divides by 0. I want to output a warning or an error message. So that's where exception handling comes in place. Because if you try and do this, right, let me show you. Let's it should run though. So let's do this. Let me say cout 10 divided by 0. Should output an exception. It should, or it might even give a warning. Yeah. Floating point exception called dumped, whatever that thing is, but it's actually an exception. So let me say int num equal to 10 divided by 0. I just want to see if it should still show the same answer. So let's build and run. Yeah, it's floating point exception. It's not clear. That's why sometimes, yeah, there's some languages that are really good because they make sense and some don't. Because, for example, in Java, right, or Python, it tells you exactly what is going on. In Python, I think it says division by 0. I think it says division by 0. Even in Java, it's something like that. It says division by 0. So you see, okay, there's somewhere in my code where I'm dividing by 0. But then when it just tells you floating point exception, you are clearly, you become clueless. You're like, okay, what is going on here? So you see, imagine you gave someone this app and then they were trying to run and then they get this. They don't understand what's going on now. You would have to handle that exception, the exceptional case that something might happen. You're supposed to handle that. So every code that you know is gonna trigger something like that, you put it inside the exception. So I know this code is going to trigger something. So I'm going to do this, right? And then I'm going to handle the exception. Just that now I'm creating my own exceptions. So I will have to define it first. So I'm going to call it division by 0, right? That's what I'm going to call it. And it's also a type of exception. Like this, division by 0. So what happens is that you need to check, you need to make sure whenever, let's say somewhere along the lines, maybe somewhere in your .cpp file, in some file, you were getting this input and then solving it via the function, right? So let's just imagine that. Let's just imagine this is some file, and then I had a function to divide, right? Divide and give you the answer. So what I would do is I'll take that, then I'll call it divide, like this, right? It takes in some integer, some number, right? And then it tries to divide. It tries to divide, okay, let's just say it's supposed to divide 10 by some input. So we divide 10 by the number that we get from the user. So before I divide, remember that the user might enter in a non-realistic value like 0. Division by 0 doesn't make any sense. So I would have to create an if statement and check if the divide variable is 0 or has the value 0, I will throw an exception. It's like, for example, your dog or your pet, whatever, you throw a bone. Obviously, it's going to try and what? Catch the bone. So that's what we're doing here. I'm throwing an exception. So division by 0, I think it should be like this. So you say division by 0, and then, okay, I know why it's complaining. Yeah, I should say division by 0, right? So you throw that exception. So imagine here, you are like, for example, throwing bone or a ball. Let's just say a ball for your dog to catch, right? You are throwing the ball, right? And then here, this is where this is where the dog catches the ball, right? It's as simple as that. Throw and catch, throw, catch, throw, catch. It's that simple. So if I try to divide by 0 and then I get if I try to divide, I check the divisor. If the divisor, this is a divisor. Basically, divisor is a value that we divide by. So it's a divisor. So I'm just going to check if that's the case. If that's not the case, it's going to skip. Remember that the if statement only executes if the condition is true. So if the condition is true, the divisor is equals to 0, then it will throw an exception. And when it throws an exception, that means the program will it's gonna do something. It's gonna it should do something. We're gonna handle that. And then at the end of the day, it should return 10 divided by the divisor. If this is not the case, then it's gonna skip and just divide. Because remember, we can divide by negative values. Still fine. The only thing that we can divide by is 0. So now I'm going to change this exception to division by 0, right? So we're going to get the input from the user. So cin, and notice the direction of the arrows. So I'm taking from what the user has typed and putting it into some variable. So, and yeah, obviously this is going to be we're getting a divisor from the user. And then just remember, this is just a different way of initializing it. This is a C++ way of initializing variables. I like using that way because it's more modern. So I'm going to get the input and then put it into the divisor variable, right? Then after that, I'm going to try and call my divide function. Divide, right? And then it takes in a divisor. And then now what's going to happen is obviously the program is going to terminate. So what throw does, right? It's sort of, I think it does return an integer. I think we're gonna be working with integers. We'll check. Because remember the caller, any function, it takes in an integer to represent success. You see here, it took in an integer, we returned an integer 0 to tell the program or the compiler that okay, everything was successful. So when you use these ones, the classes or exception handling should throw a different value other than 0. Obviously, it knows okay, this is not 0. That means something went wrong, so I need to handle that. So this is me actually catching the ball here. I'm handling the error here now. And look at where I placed the code within a try. I'm telling it to try this. And then if it happens that someone enters a value that throws this, then catch it. After catching it, what do I do? Let's say cr output an error message and say cannot divide by 0, or division by 0 is not allowed, right? That's all I have to put there. This is what's going to inform the user, and I need to write a clear error so that the user can understand that, oh, okay, division by 0 is not allowed here. So let's build and run. Didn't I put in a divisor there? Oh, it's supposed to return a double because I'm actually returning the value of the void. Okay, so I must enter a value. Let's say the value is 100. The value is fine. Okay, it is not. Oh, okay, I see what's going on here. Let me see, but it should be fine though. Yeah, 10 divided by that should be fine. So divide, Why isn't it outputting? It should be outputting though. But yeah, this is how you'd structure it. So let's say 5. Yeah. Okay, so yeah, you see I entered 5. 5 is positive, right? So 10 divided by 5, that's 2. And then I don't know why it's not. Okay, I think I see why. Let me do this. Let me actually store the answer here, because now I feel like it doesn't, it's only working with integers. So if you get, for example, 0.3, it's always going to round that to 0. If, from the looks of it, it's doing that. So I don't want it to do that. So I explicitly store the answer into a variable. So obviously, if I try to divide by a number like 35, let's say 35. Okay, it still does show 0 there. It shouldn't be showing that. But yeah, it shouldn't be showing that. But let's try then the negative, the 0 division now. Let's say I try to divide by 0, right? I'm going to enter the value 0. That's the value that I'm going to divide by, right? So I enter that, and then you see cannot divide by 0. So it tells me that I cannot divide by 0. So that's basically, in a nutshell, that's what exception handling is for. We're handling errors that might occur, and when they do occur, we handle them in a proper way than just doing if statements and checking if this, if that, if that. Yeah, you can't just work with if statement. For example, just say if divisor and then just say cout or cr. Yeah, it's not. So exception handling is more efficient than if statements. Obviously, you might have to work with if statements along the way to actually use exception handling. For example, I use an if statement here. So yeah, this is the flow. This is how you handle it. So that's what they want us to do. They want us to implement this, and we already have this exception, right? The file not found. So we're gonna handle that. So let's go back here. So basically, what should happen is that we should copy these 2 lines, because they want us to show the whole the code, right? So I should copy these lines and put them inside a try to show them that I'm trying this code. I'm trying to run something that might output errors. For example, I might not find the file, so I have to put that there and then catch. Remember what he called it? I called it file not found exception. What I called it, file not found exception. And then if the file wasn't found, I just output an error message. File not found. And that's pretty much it. That's all you had to write there. Because remember, you've already created this class, this exception. So you don't have to worry about where it's coming from. It's already created in the previous question. Let me just double check something here. Okay, I see. I just wanted to double check something. So yeah, this is how you're supposed to answer that question. You put in that whole code inside a try, because that code is buggy. In a way, I would say it's buggy. It might it might let me say let me say let me not say bug. I would say it might give us runtime errors. So whenever while we're running the code, there might be errors. Those are called runtime errors. So since we know there's a huge possibility of that occurring, I use exception handling. I put it inside a try. I try that code because I know it might raise an exception. And then when it raises or throws that exception, I catch it. What did I call it? I called it file not found. And then I create a variable here called ex. You usually use this. Yeah, but don't worry about it now. Yeah, you don't have to worry about it now. But yeah, this is how we would approach it. I just want to check something here. Let's see C++ does store this. How does it store it? Okay, makes sense. Yeah, C++ is very demanding. I'm thinking about it. Remember, this is a class, so and you didn't overload this operator, so we can't print that. So yeah, so you don't have to worry about this EX. You don't have to worry about any of that. Just write it like this, handle the exception, and then done. Move on to the next. So this is how they wanted you to answer this question. You put everything inside a try. You know, any code that you know at some point or at some level, it might create issues. So the user might you might create runtime errors. So when the user is running the application, there might be a runtime error. Maybe we tried to open the file and we couldn't open it, or we couldn't find it, or the user enters a value 0 and our app does division. All of those errors, they might occur. So that's why you had to put all that code inside the try this, and then what try knows is that, oh, so this code might throw something, and whatever it throws, I must catch it, and then use the catch to catch it. So if you catch what you've thrown, I threw a ball that's pink for my dog to catch. Obviously, the dog is gonna catch that ball that's pink. It can't miraculously catch a blue ball. The ball cannot miraculously change along the way or in the air. It can't do that. So just keep that in mind. So we are done with 2.3. And then let's see. Should I create this? Nah, let me not create it now. This is a topic on its own. I feel like we have, before we attempt these questions, I'm gonna have to go through the textbook with you guys, then show you what's actually going on. Yeah. But it's very straightforward. You see this question here. It's worth 15 marks, which is 15%. This should be a guaranteed mark, this one. Guaranteed. Don't have to worry about all of that you're seeing. And as you can see, the way you're seeing it like this, it's exactly like that. Just keep that in mind. It's exactly like that. When you're coding it, it's going to code it exactly like this with these arrows and everything. That's what I like about C++, even though it can be demanding. But when it comes to algorithms, I feel like, yeah, it's the way to go. So write the necessary C++ code for the following statements and answer the remaining questions. Unless otherwise indicated, you may assume the necessary header files are included. Most of the marks in this section are awarded for file handling operations. So basically they're saying, don't worry about including and whatnot, header files, whatnot. Just write the code because the marks is in the code. That's what they're telling you guys. So the data represents the water levels over a number of years, right? Over a number of years. Over a number of years for several dams. So there's more than one dam. So this data represents the water levels for each dam over a number of years. Each line represents the water levels for one specific dam, exactly. This information is for each dam. So line 1 represents one dam. So they are, or they can be, an arbitrary number of dams. So arbitrary number of dams, meaning that they vary in length. So it's not like fixed. It's sort of like dynamic. And the lines can vary in length since not all dams have existed for the same number of years, right? So each value in a line it's separated by a space character. It's separated by a space character and has the following meaning. So this is what we need to create, something like this. So write code which reads the values from the file and outputs every dam's name and the lowest water level percentage. A water level percentage cannot be greater than 100. So, okay, we don't have to worry about record structures here in that question. We're only going to worry about the record structures down here, starting from 3.2 going down. So we'll do 3.1 now and answer it. So basically 3.1 is code, it's implementation. So I'm gonna have to write it inside code blocks. I feel like that's better. So we have done the exception handling. We don't need any of this. Don't need any of that. So we're gonna have, for example, a function called load from text file, right? And since we are told the file name, okay, let me see. We actually don't need the function. Yeah, because we're told the file name, they didn't tell us to put it in header files and all of that. Yeah, so, and they even give us the file name, yeah, it's very important. So meaning that we don't have to create a header file and create class, put this function inside a header file inside of a class, implement it inside the CVP file. Now we don't have to do any of that. We just implement it. Just want to see you start coding, right? So obviously, before I start coding, I'm gonna need to work with files. So I'm gonna need to work with the stream of files or the file stream. So I'm gonna say hash include and I say f stream. F standing for files or file. So I'm dealing with files. And then obviously I'm gonna need to create an instance of the file, right? Or a variable of that file of the fstream class. So let's see how we can go about doing it. So what are we supposed to do here? Let's see what exactly you're supposed to do. Are we reading or are we writing? And when you check, it says which reads the values from the file. So we need to read the file. So remember, when you're reading from the file, it's regarded as input. It's like, for example, reading from the terminal. Remember cin, right? It's input. I'm reading. You can regard that as reading from the terminal. So that's what we have to do here with the files. So since I'm reading, I'm gonna remember that's always an fstream object, right? It depends on which type. It could be an I or an O fstream. So I'm dealing with input, so I'm gonna put an I there, fstream. And then I'm gonna call it file. I'm just gonna call it file, right? And then don't forget to close the file. So I'm gonna say file dot close, and there we go. Close the file, right? So we close the file, and then yeah. So once I've closed the file, let's try reading the file now. So we're gonna start by opening the file. You can't close the file that's not open, right? So you need to open the file. Let's open the file. Oh wait, I forgot to put the answer here. This value, answer for 2.3, then color there, color there, cat should be a color too, this should be a color too, this should be a color too. So yeah, that should be fine. 2.4. So let's continue where we left off. So in order for you to read from the file, you need to open the file. So file dot open, right? Then what's the name of the file? So you need to put in the name of the file. Okay, I deleted what I copied previously, so I need to copy it again. So water levels.txt. This is the name of the file, right? So I open the file, and then after opening the file, I need to close it. So what's happening is that I'm going to my files, right? Where the files are and everything, but within my project, because remember, I'm inside code blocks. You can only access things within that project that I've created. So if I want to open the file, I'd have to add it to my project. So, but I'm just showing you for demonstration purposes. Like, what are we actually doing? So it's like you're looking for a file, right? Let's say this file, and then I'm telling the computer to open it. So opening it means to do what? To just double click, and then it opens the file. And then after opening the file, I'm gonna need to read the contents of the file, but I'm coding it. I'm not literally going there. And then after reading the file, I need to close it. How do you close it? Presses that X value there at the top. Then boom, it closes the file. So that's exactly what we're doing here, but I'm coding it instead of literally going to open and read the file. I'm writing it as code. So let's see. Let me see. Okay, not exceed 20 characters and 100. Okay. Let's see. What is this? Oh, okay. The files are a bit different. Okay, I see. So we have a text file and a binary file. So, and the way we read them is going to be different. So let's do that. What did I want to check again? Oh, I wanted to see the structure, right? So let's see. We open the file, right? And then when you're opening the file, remember that there's the modes that you specify in what mode are you opening the file. In our case, you don't need to provide a lot of anything else because by default, it I think by default it does. Yeah, by default it reads it reads it as a text file. So you don't have to worry about the modes. But you could do and say iOS, and then you say in for I'm reading as an input, and you combine that with another one, anything, maybe appending or whatever the case is, or in binary, if you're reading this in binary mode. Yeah, we don't have to do anything. With text files, you typically just like that, text files. But with binary files, we have to specify because by default, it's gonna read the text file. It's gonna read it in a text file mode, not in binary mode. But then when you get to binary, you'd have to write it in that way and say iOS binary so that it knows, oh, you're reading it in binary mode now. It's no longer text by default. So we have this file that open, and then now it's time to read this information. So the way I like to read this information, right? The way I like to read it is by doing a get line. So I get the line, I get each line of the file. So you can use the get line function for that. And then that line that you get, you can put it into a string. And then yeah, it's gonna be quite an interesting way to read it, but just bear with me. You understand as soon as we start coding. So I'm gonna do a while loop, right? So while there's a line to read. So while get line, so if it's able to get the line, then it will read it, and we're gonna put that while loop there. And then every line that we read, we're gonna put it into a string. So I need to work with strings. So I'm gonna say hash include string. So I'm gonna need to work with strings. So I'm gonna say string, and then that's the line that I'm reading, and then that string I just initialize it to empty curly braces to an empty string. And then while I'm getting the line, what line am I need to specify the input stream. Basically, where am I getting it from? As you can see, it's written here. You see, it's a character, basic input stream, and text in a string. So what input stream am I getting it from? From this file, if stream, that's the stream that I'm getting it from. And then I store it inside the line variable. So now I have a line that I've read from the file. If you check this file, this is the line. So I've read this whole line. Now I need to find a way to extract all the information one by one, all of this information one by one. How do I do that? This is where your friend comes into play. The string stream that you guys have been working with this whole time. So we're gonna use the string stream. So with the string stream, right? Remember that the string stream it's a stream for strings. So we are able to work with strings using that string stream. So the way we're gonna do it is, remember the way it works. It works the same as cout. It's a stream. At the end of the day, it's a stream. Same way as cout, and the same way as cin. It's gonna be working exactly like that. And if you notice one thing about, okay, I'm just gonna write this here. I will do that later. I just want to demonstrate how to. Don't worry, don't raise any errors because I didn't do exception handling or if statements to say if I couldn't open it, I'll put an error. It won't do anything. I'm not worried about that at the moment. So I just want to demonstrate how I'm going to approach it. So I'm going to approach it like this. So for example, remember we have values, right? So let's say we have this, then I have some string there, then I have 90, and then I have 9.0, whatever. So remember what this means. It means that after each space, I can read in some new different information. And we've been doing that with cin and cout. So for example, let's say I have a string and this is someone's name, right? And then I have age, which is someone's age. And then now I'm going to read it in this order. So read from the stream age first. Then after that, read the name. So what's going to happen, right? It's going to follow this structure. It's expecting it to be in this format. So 12 should be any number, and it should be an integer. Okay, it can be a double, but what's going to happen is that it's going to read only this, and then it will continue from the dot going forward, because the dot is not part of an integer. It doesn't represent an integer. So it's going to make sure that it's a whole number, and then the next available thing. So basically, any amount of spaces that I have, the next available input that I'm getting could be hello or hi. That's what it's going to start storing it inside name, because it says okay, that's the string now. So this is where the string starts, and then this is where it ends. And then this is where the integer starts. This is where it ends, because after 3 there's no number, there's no int, there's just spaces. So it stops there. It stops reading the integer there. And then when it gets to cin, it like, okay, so when it gets to name, which is a string, it looks for the first character. Oh, there's an H, there's an I. And then, okay, there's no letter after I, so I'm done reading. So that's basically what happens. It could be one space like this or multiple spaces, doesn't matter. So this is what's going to happen. it's going to read that information. So I'm going to say user's name is, and then I'll put their name there. And then also output their age. So it's going to be age and line, right? So what's going to happen is that it's going to look for this format. It could be, it's basically from one space and above. If it says, the moment it says a space, like, okay, this is where it ends. Whatever I'm reading now, this is after the moment it says a space, like, okay, that's, I stop there. So it's gonna stop at 1, 2, 3, at 3. So when I enter 1, 2, 3, and then I can put as much spaces as I want, it doesn't care. Then I get to pi, right? So what's going to happen is going to store the integer first, 123, and then it's going to look for, continue reading, like, okay, wait, there's no number anymore, there's no integer anymore. So I stop there. And then it looks for a string now. Oh, there's a string there. And then there's age, that's where it starts. And then there's I, okay, there's nothing after I, then I stop there. That's what it's going to do. So if I run this and I press enter, there we go. There's the name, hi, there's the name, age. So I'm gonna use that same concept with input streams and output streams. I'm gonna use that same concept but with strings. So I'm gonna create a string stream like this, and then yeah, it depends on what I'm reading. The thing is, they didn't say anything about. I don't know where we're supposed to be storing it. Let's see. And outputs every dam's name and lowest water percentage. Or I should output every dam's name. So the first thing that's going to be there is the name. But remember that I need to insert, right? I need to sort of like input. So remember that I did take the line. So the line is stored here. Line of values. There's the dam name. It could be, let's say dam1. Then there's a space. Then we have the dam region. Then we have dam region. There's then the space. And we have what is this? A set of real values. Each value represents the water level percentage for that dam in 1 year. So it's a set of real values. So it's just basically percentages. Yeah, it was just a collection, an array of percentages, right? So array of percentages. So that's what comes after that. But they phrase it like this to keep it simpler. So from R0 to Rn. And last thing, okay, that's it. So remember, EOL means end of line. EOL basically means end of line. Basically, it means to start in the next line. That's what that EOL means. EOL just basically means they did put in line character there. So just keep that in mind. So this is what I need to read. And they said, if you look at this, they said the percentages, right? I think the percentages are not the same. Yeah, the percentages shouldn't be the same. They said the water levels over a number of years, right? And then the water levels are actually those percentages. Each line represents the water levels for each specific dams. The percentages for that water level, yeah. So there can be an arbitrary number of dams. Yeah, there's so the dams, okay, so the dams number is not fixed. We don't know how many there are. And the lines can vary in length, right? So since not all egg dams have existed for the same number of years, each value in a line is separated by space character and has the following meaning. The dam name, it's a string, not longer than 16 characters, right? So it reaches a maximum of 16 characters. That's what it reaches. So you need to keep that in mind. So since it reaches it doesn't reach more than 16 characters, what I'm going to do is I would have to, this is a string, and it's going to be 16 characters. And this is going to be real values. So we have that, right? So 16 characters basically means that I need to make it a character like this with a fixed size. That's basically what it means. And it can't be more than 16. So I have to create it like that. It can't be more than 16. So I'm going to call it characters like this. It can be more than 16. And I'm going to initialize every character there. Okay, I'm just going to put it like this, leave it empty. When I leave it empty like this, it automatically initializes every value in the array to be the default value of a character. So yeah, I'm just going to leave it like this. If you want to specify every character and waste a lot of time doing that, you can put in 17 times, 16 times this and keep repeating. Yeah, but that's not necessary because I can just write it like this and then it will do that for me behind the scenes. Then I'm gonna need a string which is the dem. There's gonna be an empty string at first. And then I'm gonna need the real values. The real values, though, we're not sure how many they are. We have to check. Because it seems like there's more than one, if I'm not mistaken. Seems like there's more than one. Okay, it doesn't. It's nice because I keep reading until I reach the last value. Okay, so it's actually not too bad. So the dem name, that's the first thing we need to read. So in order for me to read these values, right? So imagine like this. Let's just make it an example, right? Let's say we have a dem name, dem1, that was the first dem, and then a space and the dem region. We call this region 1, right? Then we have values, let's say 9, 3, 2, 4, 5, something like this, right? So, and then remember the approach that I'm taking is that I'm reading each line and storing it inside the line string. So it's going to read all of this and then store it inside the line string. So basically it's going to be like this. This is what this line does. It says line is equals to the line from the file like this, right? So I have this string. Then I'm going to push the string, or I'm going to push the characters one by one into my string stream. The same way we're using cout. That's how I'm going to push it. But at least now I know I'm pushing it into a container for strings. So I know I'll be able to insert and take the same thing that I insert. So and I take it back in the same order. So if I first inserted dem1, when I extract, it's gonna start extracting the first thing that came in, that went in. So and then after doing that, I'm gonna use my string stream to extract. I'm gonna use the string stream the same way I use cin to now extract all of these values. I extract the dem name, this, and the values. So how are we going to do that? So let's insert into the string stream. Insert the line into the string stream. Let's insert the line, and my string stream is represented by that variable ss. So insert into the string stream. This is how you insert. Remember, this operator is called the stream insertion operator. We are inserting. So insert what? The line that I've received from this file. That line that I took from this file, insert it into the string stream. And then now from the string stream, extract the information. So I'm going to use it the same way as cin. I'm getting what? dem1. What is dem1? It's a string. And I've already created a variable for it. Okay, it's not dem, it's dem. So I'm going to extract it into dem. So I'm extracting it where? From the string. What's happening is that, remember the way I inserted it. You see this line, right? This line is basically saying, this is my container, right? Basically saying add this. Then add this into this container in the exact same order with the exact same spaces and everything. So it's going to take this in the next iteration, then put it like this. Then now, when I want to retrieve from it, I retrieve the first thing that I added, followed by the next, followed by the next, and so on. So I'm going to start by extracting the DEM, because that's the first thing that stay in the file, and that's the first thing I inserted into my string stream. And then what's the next thing? It's the region. Check the region. It's characters. Let me see. Characters not greater than 16. Let me see. I could read it as a string. Yeah, it's gonna be okay. It's gonna be complicated. There's many ways you can approach it, because I'm trying to avoid this thing of having to store a value, and maybe having to use the string and then reading a value that's too big, or having to use characters and then obviously it's gonna also store the empty character. I want to avoid that, so I'm just gonna create a string temp variable. That's for temporary. It's going to be store the region, and then after storing the region into that string, I check the length of the string. Make sure it's not greater than, the length is not greater than, yeah, I check the length that is not greater than 16. So I'm going to check if the string, what is the string? It's that temp variable, right? Dot length of the string. Yeah, the length function is pre-installed inside the string class. So you don't have to worry about where did I get this function? It's inside any instance of a string. You see, string. If you go to temp, it's a string. So it's any instance of a string. You can get the length of that string by calling the length function. So I check the length. I'd say if length is less than or equals to 16, that means it's not greater than 16. Then now I can transfer the characters one by one. I can transfer the characters into this. Transfer the characters into this one-dimensional array of characters. So I'm gonna do that now. I mean, there's actually no need for this, but yeah, there's actually no need for me to transfer them. It's gonna waste time because I already have the string, and that's all I need. So I'm just gonna use this when I have to output and do all of those things. I'll just make sure it's valid. So for now, I'm just gonna leave it like that. Wait, let's just avoid all of that. Let me just transfer, man. Let me say for int I is equal to 0, I is less than that string's length, then I plus plus. And then I'm going to say the characters index at index I is equal to my temp variable at index I. Then remember the string, right? You can index into the string because the string is basically a one-dimensional array of characters. So that's why this is going to work. So just keep that in mind. So building, there's no errors, that's fine. So we did indeed get the characters properly, and we made sure that they don't exceed 16. So now we are done reading the region. Now we need to read these integers. So how do I read the integers? I use another while loop because I'm not sure how many integers are there. I was not told. You see, the same way I'm using getLine. getLine is very useful because I don't know how many lines are there. And it's the same thing that I'm going to do with this string. I'm going to get from string and create that one-dimensional array of values, right? And since I don't know how many values are there, I'm gonna use the very useful data type, vector. We're gonna use a vector because it resizes automatically. Whenever you add an element, it increases the size by 1. Whenever you remove an element, it decreases the size by 1. So we're gonna use that because we're not sure how many integers are there. Then I'm just gonna create an int num variable. That's for storing the current integer before I add it to my array or to my vector. So obviously I'm gonna create a vector of type they said real. So I'm gonna use doubles and then vec values, right? And then at each index, I'm just gonna initialize that to 0. I think that should work. Yeah, that should work. Yeah, every okay. I think I should just if I put in that value, it's only gonna initialize the first one. I wanted to initialize everything, so I'm gonna leave it empty like this. So now this vector will be able to. It's gonna have a default values of 0 for every vector. By default, it has a starting size, and then it resizes as time goes on if you exceed that size. So it's going to initialize every element that's in the vector to 0. So now I'm going to read. So how do I read? I use a while loop. So while my string stream, there's something to read, which is an integer. How will it know it's an integer? Because I'm storing it inside num. Num variable is an integer. So while there's something to read, add that value to the vector. How do we do that? Vec values dot push, right? And then you add the number like this. Should be fine. Yeah. So you say dot pushback. Pushback means push it to the back or to the end of the queue. So imagine you're in a queue. Obviously, when you go to a queue, maybe you go into a bank to an ATM, then there's a queue. They push you back to the queue. You can't go to the front. You're going to be pushed to the back. So it's exactly the same philosophy. It's going to be added to the back, add to the back, add to the back. So it's like this. If there's no value, it's obviously going to add it to the first index. So it adds it there. The next value, obviously, add it to the back, add it after. So it's going to be like this. We get 10. Where does it go? It can't go to the front. It can't go in the middle. So it adds to the end. So it adds 10 to the end. That's what this pushback function does. So yeah, we've successfully read all the values from the file. Yeah, we've successfully read all the values from the file. Now we need to start outputting what they want us to output. Yeah, as you can see, they want us to find the lowest. It is 5 marks. They don't come easy though. Yo, this is a lot of thinking. These 5 marks don't come easy, you must think. So we have every dam's name. So you must output every dam's name. As long as it's a dam, just output it. So this is actually the dam name. So I'm gonna call it dam name to keep things simple so that in output it makes sense. So we need to output the dam name, this in line, right? Dam name. And then the lowest water level percentage. And they're saying that the water level percentage cannot be greater than 100. So I'm also gonna so in order to avoid all of checking and whatnot, I'm going to come here and do this and say if the number that I'm trying to get is less than or equal to 100, then it does qualify to be added to my vector because it is less than or equals to 100. It doesn't exceed 100. So we just added that line there. So we are good to go. Now we can find the maximum within the vector. How do we do that? You could, let me say, like, what did I call it? Let me not call it vec values like that. Let me say underscore values. Like, yeah, the underscore approaches. Yeah, naming your variables is like with underscores is fine, it's better that way. So yeah, we have vectors, right? You could, I don't know why it's not suggesting. I wanted to check. There is a function. I think there's a sort function. There's the there is the sort. There's a sort. And then yeah, you don't. But you can't use the default function inside C++ because you're gonna lose marks. They want to see all of the code. So and yeah, and before it makes sense before because you can't use something that you don't know how it was implemented. So you should be able to implement it before you can use it. So I'm gonna say int I is equal to 0. Remember, all arrays start at index 0 in most programming languages, but in C++ definitely start at 0. And then I'm gonna go to the vec values dot size. I don't know why it's not helping me out with the IntelliSense, but yeah, I'm gonna check that later. Yeah, so the size function is basically like it's like the dot get rows or dot get size or length function. It gets the size, it gets the number of elements that are there. So yeah, we have that. Now we can do what we want to do, right? So I want to find the lowest water level percentage. Okay, let me do this. Okay, check that later. So it's supposed to output the lowest water level percentage, right? So let's do that, the lowest. So I'm going to create a temporary variable called lowest water level. Okay. Just give me a sec. Yeah, lowest water level, and then initialize it to 0 using the C++ way. And then, okay, not 0. Let's initialize it to the first element in our vector. So we're gonna work. That's how this algorithm usually works. You assume that the first value in your array is the maximum because you need something to compare it from. We need to start from the beginning and then we compare to the next value and the next value and the next value. So I'm gonna use the .get function. Get at index 0. That's the first element. And then after getting that value, now we can compare it. I compare the current lowest water level that I have, and I compare that with my. Okay, let me just phrase it in a different way. Let me just get the current value, right? Let me say vec for values dot get index I, the current element, get it, and then check if that current element happens to be less than our previously assumed lowest value. If it is indeed less than that lowest value that we assumed to be the lowest value, we update our lowest value because clearly it's no longer the lowest value. So I'm going to update it to this current value like this. And then that's it. You're done finding the minimum. And then now there's something that we need to fix that's important. So remember, we are initializing it to the element at position 0. The first element is our lowest. So obviously, I don't want to start from the first index because I already assumed that's the highest. I want to start at the value after it and compare it with the current value. So I'm going to change this to a 1. It might not look not like necessary, but yeah, you could save a lot of time. Yeah, you don't have to compare. You can't compare yourself with yourself. Obviously, you guys are the same. It's the same value. I can't start from index 0 when I already previously assumed that the minimum value is at index 0. I can't do that. So it should also output the lowest water percentage level. So let me do that. Let me output the lowest water level. So I'm going to say C out lowest water level and then inline. Then that's it. That's all you had to write for that question. So let me try and do this. Insert refactor folding. Okay, did okay, did format. Yeah, I just recently formatted my file. Okay, I now know how to do that, but that's not what I was looking for. Let me see. There was an option. There's this option that I want. Let me see. Main.txt. Yeah, I'm gonna save it like this. So yeah, it's gonna, let me see, view perspective. Yeah, so I'm gonna save it like that. So that I have access to that document. Let me see. I don't want to, but I wanted to sort of, like format, keep the code blocks format. Forgot how to do it. How do you save it in such a way that you should be able to save it in such a way that oh, I think it's print. Yeah, you put print. You put it in print. Yeah, so print, and then let me see. It's not formatting correctly though. I don't like that. I don't like that. So I'll just keep the text file. We're just gonna work with that as the solution. Let me see. Okay, I've spent a lot of time on this, so let me just pause it from here. Or maybe I can still do, okay, let's just, I think I would have to explain a lot. I don't want the videos to be too long. So I'll just see you guys in the next part. Okay, stop recording.